Have you ever wondered how banks calculate the interest on your savings or loans? Or perhaps you're trying to understand how investments grow over time. A key concept in all of these scenarios is the interest rate factor. It might sound a bit technical, but it's actually a very straightforward idea that helps us understand the power of interest. Imagine you're planting a seed that grows a little bit each day. The interest rate factor is like the multiplier that determines just how much bigger your plant gets each day. It's a way to express the effect of an interest rate in a form that's easy to use for calculations, especially when we're looking at periods longer than just 1 year or 1 month. Let's break it down. We all know what an interest rate is. It's usually expressed as a percentage like 5% per year. This percentage tells you how much extra you'll earn on your savings, or how much extra you'll pay on a loan, for every period, like a year. The interest rate factor takes this percentage and turns it into a multiplier. To get the interest rate factor, you start with the number 1, and then you add the interest rate to it, but you need to express the interest rate as a decimal first. So if the interest rate is 5%, you convert that 5% into 0. 5. Then you add 1 to it, giving you 1. 5. This one. 5 is your interest rate factor. Why is it called a factor? Because you multiply it by your initial amount to find out the amount after 1 period. Let's say you deposit $100 in a savings account with a 5% annual interest rate. To find out how much money you'll have after 1 year, you multiply your initial $100 by the interest rate factor, which is 1. 5. $100 multiplied by 1 is 3. 5 equals $105. So, after 1 year, you'll have $105. The extra $5 is the interest you earned. Now, the real magic of the interest rate factor shines when we talk about compound interest. Compound interest is essentially interest earned on interest. It's like your plant not only grows bigger each day, but the new growth itself also contributes to even more growth the next day. If you leave your $105 in the savings account for another year, you won't just earn 5% on the original $100. You'll earn 5% on the entire $105. To calculate this, you use the interest rate factor again. You multiply the $105 by 1.5 that y. This gives you $110. 25. Notice how the interest earned in the second year is more than the interest earned in the first year. This is the power of compounding, and the interest rate factor makes it easy to calculate. For each year, you simply multiply the amount from the previous year by the interest rate factor. You can also use the interest rate factor for loans. If you take out a loan, the interest rate factor helps calculate how much you'll owe over time. It works in the same way, but in this case it represents the growth of the amount you owe rather than the growth of your savings. So, the interest rate factor is a simple yet powerful tool. It's essentially a multiplier that incorporates the interest rate, making it easy to calculate the future value of investments, or the total cost of loans, especially when considering the effects of compounding over multiple periods. It helps us move beyond just thinking about the percentage interest rate and directly see the impact on our money. It's a fundamental concept for anyone wanting to understand how money grows or how debt accumulates over time.